All right. Good morning. Module 5, Lesson 18. Problem number 1. First, I'm going to give you guys a little quiz. So, can you give me the least specific name for all of the shapes that we have drawn so far? The least specific. Quadrilaterals, right? Quadrilateral, that is the least specific. Every shape we're drawing is a quadrilateral. It has how many sides? 4. Okay? Yes, it is a quadrilateral, but it's also something else. So quadrilaterals are the least specific name. Now, what is a more specific name for a shape that we have drawn? Trapezoids. Okay, a trapezoid has at least what? 1 pair of parallel sides. We have also drawn a parallelogram. Parallelograms have 2 pairs of parallel sides. So today, before we begin, we're going to do some more questions. How did we start drawing the trapezoids and parallelograms? What was the first thing that we did? Correct. We drew 1 pair of parallel sides. If we wanted to draw a parallelogram that is also a rhombus, what would we need to think about? So today, I think you just heard what we're going to be drawing today. Today, our target is I can draw rectangles and rhombuses to clarify their attributes and define them based on those attributes. So today we will be drawing rhombuses and rectangles. So think about a rhombus. What is different? How is a rhombus different than? It is a quadrilateral. How is it different from a parallelogram and a trapezoid? Rhombuses have 4 sides, like all the rest of them, that are the same length. So yesterday we technically drew a rhombus, or I did, because I made on our problem set this one was a rhombus right here. All sides were the same length. So I made that yesterday. Okay, so rhombuses have 2 pairs of parallel sides, but we have to make sure to measure to be sure we drew all the sides the same length. So now we're going to draw an angle with sides that are equal length, and we're going to label the vertex as B and the endpoints as A and C. So we're going to make an angle, okay? We're going to do an angle at 110 degrees. And okay, so there's our angle. So the vertex, which is where these two segments meet, this vertex is called B. And then we have endpoints here that are A and C. But what I want to do first is I want to measure to make sure they're the same length. So I'm going to make these about 2.5 inches. There we go. Two and a half and about 2.5. So now I'm going to label my endpoints as A and C, and this is 2.5 inches. This is 2.5 inches. Okay, so here's our angle. The vertex is labeled B. The endpoints are A and C. What is the most specific name for just this shape? What is this shape? It's an obtuse angle, right? It's bigger than 90 degrees. If we had another line segment that connected C to A, we would have a triangle. So now what we're going to do is we are going to make our 110 degrees. Make sure it's lined up here. And I want it 2.5 inches. Okay. Yep, 110 degrees. And then my straight edge across the top. So the angles that are next to each other, so this angle B and A should add up to a straight line or a straight angle, which is 180 degrees. And there are two pairs of angles. So now we have D over here. And again, each pair adds up to 180 degrees. So this angle, I put it at 110, right? But it's an acute angle, so we know that it's smaller than 90, so it's 70. 70 plus 110, which is this obtuse angle over here, are going to give us 180 degrees. So this is 110, this is 70. This is 110, and that angle is 70. All adding up to 100 degrees. 180, I'm sorry. Okay, so these opposite angles on a rhombus are the same size. The opposite angles are the same size.